Before I dig deeper into the communication protocol itself, I want to compare the PS2 protocol to the I2C protocol. Both of them are serial communication protocol, but they have some differences. So the first is actually both of them have two lines, one for data and one for clock. However, for the PS2, the two lines are bidirectional as opposed to the I2C. Only the data is bidirectional. The clock is not bidirectional. So now both protocol uses open drain technology. So you have the bus in idle is actually in high because it's connected through a pull-up resistors to the positive voltage. And in the PS2, here's one of the differences. In the PS2, actually the host and the device can start a transaction. Whether you're a host or whether you're a device, you can start a transaction. In the I2C, only a master device can actually start a transaction. However, the I2C supports multiple masters, so multiple masters can actually start the transaction, but you have to be designated as a master as opposed to a slave. So the PS2 does not use the terminology of master and slave. It actually has something called a host or a device. So what's a host and what's a device? Well, a device is actually, generally speaking, either a mouse or a keyboard, while a host is usually a PC, an FPGA board, or maybe one of these microprocessors, the small microprocessors. Bottom line, the device is actually a mouse or a keyboard. The host is something that reads from a mouse or a keyboard. So in general, the host reads data from a device most of the time, because if you're connecting a mouse or a keyboard, you just want to read. It's an input device, so you just want to read from it. However, sometimes the host, which is the PC or the FPGA board, can send commands to the device. So if you want to set up the keyboard in a different setting or the mouse in a different setting, or you want to change certain things in it, you can actually send it. So it communicates both ways. Okay, so clock generation, here's one of the other differences as well. In the I2C, the clock generation happens by the master device. On the PS2, actually, the device generates the clock. So actually, the mouse or the keyboard are the ones that generate the clock. So if we're designing a PS2 host driver or host, basically, we don't have to worry about generating the clocks because the clock is being generated by the device we connect to that host. So you might be just connecting this idea to the two bidirectional lines. So if the mouse or keyboard, which are devices, are the ones generating the clock, why do I need the clock to be bidirectional? As it turns out that whenever the host wants to send a command to the device, what it does, it will take over the clock, set it to 0 for a short period of time, about 100 microseconds. And that indicates to the mouse or the keyboard that, okay, the host wants to communicate with me and send me some data, maybe to set me up or something. So I'll release the data line so I can listen to it. So that's the only reason we actually need a bidirectional line for the PS2 clock. Okay. The PS2 transmits data as 11-bit packet. So the mouse or keyboard sends its data to the host in packets of 11 bits. The number seems strange, but the 11 bits are basically one to start for the start bit. Basically, this is the start of a packet. Then the 8-bit that are actually the information that we need, and then one odd parity bit. So for error correction, if you want to do this, and 1 bit for the stop. Okay, multiple devices on the I2C here can be reached by its unique address. The PS2 only supports a mouse or a keyboard, and you have to have like a couple of PS2 hosts or cores to actually interpret a mouse or a keyboard. You can't connect a mouse or a keyboard together on the same exact bus.